This is the third lectures of the series. Today we are going to discuss about the basic property of electric charges. The first property is electric charge is a scalar quantity. It is not a vector quantity. Number two, charge is transferable. That means if a charged body is put in contact with uncharged body, the uncharged body also gets charged. Actually, what is charge? Charge means there are two type of charges. Positive charge means deficiency of electrons. Negative charge means excess of electrons. That means put when we put contact a uncharged body with a charged body, the electron get transferred. As a result, uncharged body also get charged. So therefore, charge is transferable. Next property, charge is always associated with mass. Charge is always associated with mass. Charge is always associated with mass. Charge cannot exist without mass, but mass can exist without charge. Because body, some of the body may be neutral. Neutral body do not have any charge, net charge. Neutral body do not have any net charge. But what is a charged body? What is charged body? What is called charged body? Charged body means excess of electrons or deficiency of electrons. What is mass of electron? 9.1 into 10 to the power minus 31 kg. Mass of electron is 9.1 into 10 to the power minus 31 kg. That means that the negatively charged body has more mass and positively charged body has less mass. That means when we rub a glass rod with the help of silk cloth, glass rod becomes positively charged. That means glass rod loses certain mass and silk cloth get negatively charged. That means silk gains certain mass. Because when we rub a glass rod with the help of silk cloth, electron get transferred from glass rod to the silk cloth. It is already discussed in our previous lectures. When we rub the glass rod with the help of silk cloth, electron get transferred from glass to the silk. As a result, glass rod loses certain mass, may be very small, during its positively charging process, and silk will gain certain mass during its negatively charging process. So therefore, charge is always associated with mass. That means when a body gets positively charged, body loses certain mass, or when the body gets negatively charged, it will gain certain mass. So from this experiment, from this topic, we can say that charge is always associated with mass. But every neutral body do not have any net charge. That means mass can exist without charge, but charge cannot exist without mass. And next property is very important property. It is called quantization of electric charge. It is found experimentally that electric charge on any body is always an integral multiple of certain minimum discrete amount of charge. This basic or discrete charge is the charge on an electron, which is denoted by minus E and has a magnitude 1.6 into 10 to the power minus 19 coulomb, and has a magnitude of 1.6 into 10 to the power minus 19 coulomb. So this is called quantization of electric charge. The charge on any body is always an integral multiple of certain minimum discrete amount of charge. This basic or discrete charge is the charge on electron, which is denoted by minus E and has a magnitude 1.6 into 10 to the power minus 19 coulomb. That means a body cannot have a charge less than this. A body cannot have a charge less than the charge on electron. The charge on any body is always the integral multiple of the charge on electron. So this is called quantization of electric charge. Next property is additive nature of electric charge. Since electric charge is a scalar quantity, so what is total charge on the body? Total charge on the body is the algebraic sum of all individual charges located at different points inside the system. Say a system has 3 positive charges and 2 negative charges as shown in the notes. So what is total charge on the body? Q1 plus Q2 plus Q3 plus minus Q1 dash plus minus Q2 dash. So if magnitude of total positive charge is more than the magnitude of negative charge, body possesses positive charge. If magnitude of negative charge is more than the magnitude of positive charge, body has net negative charge. And this property arises because electric charge is a scalar quantity. Next property, charge is conserved. The conservation of electric charge. Total charge of a system of the universe always remains constant. Charge cannot be created nor be destroyed. It always remains constant. When we rub a glass rod with the help of silk cloth, glass get positively charged and silk get negatively charged. We know that electron get transferred. What is electron? It is the fundamental unit of charge. So electron get transferred from glass to silk. Therefore, the amount of electron lost by the glass rod is exactly equal to the amount of electron gained by the silk cloth. Electron cannot be destroyed in the process of rubbing. Glass get positive charge. The amount of positive charge, the glass amount of positive charge developed on the glass rod is exactly equal to the amount of negative charge developed on the silk cloth. So if I add both the positive and negative charge, the total charge on the system again becomes 0. That means charge is always conserved. The number of electron lost by the glass is exactly equal to the number of electron gained by the silk cloth in this process. That means electric charge is always conserved. Next property, charge is invariant. Charge is invariant. That means charge is independent of frame of reference. What is the meaning of this statement? That means if a charged body moves, then also the magnitude of charge remains the same. Invariant means does not change. That means amount of charge acquired by a body cannot increase or decrease due to velocity of the charged body. That is called invariant. And last property is the like charges repel each other and unlike charges attract each other. Sometimes a question comes, comparison between electric charge and electric mass. The electric charge on a body may have positive value, negative value, 0, but mass is always positive. Charge carried by a body does not depend upon velocity of the body. Charge carried by a body does not depend upon velocity of the body. But mass of a body increases with its velocity according to this relation. That means mass is not invariant. Mass is not invariant. Electric charge is always quantized. Charge acquired by a body always have a quantized value. Q is equal to plus minus AD. But quantization of mass is yet to be established. Quantization of mass is yet to be established. I want to discuss one question The question is given here. Can a body have a charge of 2 into 10 to the power minus 21 coulomb? Can a body have a charge of 2 into 10 to the power minus 21 coulomb? Can a body have a charge of 2 into 10 to the power minus 21 coulomb? In the quantization of electric charge, we get that the charge on any body is always integral multiple of certain minimum discrete amount of charge, and that minimum discrete charge is the charge on electron, which is 1.6 into 10 to the power minus 19 coulomb. But given charge 2 into 10 to the power minus 21 coulomb is less than charge on electron. Therefore, a body cannot have this charge. Charge on a body cannot be less than the charge on electron. Here 2 into 10 to the power minus 21 is less than 1.6 into 10 to the power minus 19 coulomb. Therefore, a body cannot have a charge of this. There is another one. A glass rod wrapped with silk cloth has a positive charge of 1.6 into 10 to the power minus 12 coulomb. A glass rod, when wrapped with silk cloth, developed a charge 1.6 into 10 to the power minus 12 coulomb. So what is the magnitude? It is positive charge. What is the charge on the silk cloth? What is the charge on the silk cloth? What is the charge on the silk cloth? Since total charge is always conserved, therefore charge on the silk cloth is equal to minus 1.6 into 10 to the power minus 12 coulomb. That means when we wrap the glass rod with the help of silk, glass acquires the charge of 1.6 into 10 to the power minus 12 coulomb. It is positive charge. So therefore, what is the charge on the silk cloth? The charge on the silk cloth is minus 1.6 into 10 to the power minus 12 coulomb. From where it comes? Because total charge is conserved. Before rubbing the glass with silk, both of them are neutral. Therefore, the amount of positive charge developed by the glass rod must be equal to the amount of negative charge developed on the silk cloth. So since the charge on glass is plus 1.6 into 10 to the power minus 12, the charge on silk must be minus 1.6 into 10 to the power minus 12 coulomb. And this comes from the conservation of electric charges. It comes from conservation of electric charges. The first question, can a body have a charge of 2 into 10 to the minus 21 coulomb? It comes from quantization of electric charge. There is another question. Can a body have a charge of 2.4 into 10 to the power minus 19 coulomb? Can a body have a charge of 2.4 into 10 to the power minus 19 coulomb? So this charge is more than charge on electron. Therefore, we use the formula Q is equal to Ne. Therefore, we use the formula Q is equal to Ne. So what is Q? Q is 2.4 into 10 to the power minus N is equal to Q by E. Q is 2.4 into 10 to the power minus 19. E means 1.6 into 10 to the power minus 19. This is 1.5. But in the quantization formula, it is said that the charge on a body is always an integral multiple of certain minimum, that is charge on electron. 1.5 is not integral multiple. It is 1.5. Half of the electron is not possible. Therefore, body cannot have a charge of 2.4 into 10 to the power minus 19